In this video, I'm going to introduce an unusual new product simply called BLACKBOX. Then I'll show you how it can power our largest experimental generator, G1, which in turn will charge storage batteries. So stick around for a few minutes, you just might want to see this. I'd like to bring you up to speed with a little background first, so please bear with me. Several months ago I made this, and I've made lots more, but it's a super cap. They're real easy to make, and it's got quite a bit of energy density. Actually, when you charge it up, it'll run a small motor for several minutes, and then when the voltage drops to a point where the motor won't run anymore, the motor will continue to demand power from this thing. Even though it won't spin, it'll be pulling amps in, and at the rate of about 120 milliamps, while it's been running the motor at about 100 milliamps. So as good as that is for these little homemade super caps, and everybody and their brother's making these days because they're so darn easy. But as good as that is, and as good as these manufactured ones are that I've been using for years, especially from Maxwell, they both of them share something in common. And they also share it with lead acid batteries to lithiums. One thing in common, and you know what it is: they all need to be charged. So, okay, that's great. So you say, all right, well, we've got renewables, so let's use solar. Well, solar's fantastic, as long as it isn't a cloudy day for a few days, or it's been raining for a week, or it's at night. That's totally useless then. Well, then you've got the backup windmill. Well, that's good. That's about as predictable as a cat. Sometimes the wind doesn't blow for 2 weeks. It may be as calm as can be. And if you're another sea coast condition, maybe it blows all the time. So, you know, it's, like I said, it's unpredictable. But they share that. They all need to have another energy source to charge them up. So, I've showed you another video, I don't know, I guess it's been a couple of months ago, of the little micro generator. That's this one here. A little over 4 volts. And then right after that video, I turned around and I made this larger one. Now you can see that it looks like it's, well, it's a little less than twice as long, but this one was 4 volts. This one has new chemistry, better improved silicon crystal cells and so forth. This one was 25 volts. 25 volts is a lot. So naturally my instinct is to destroy it, and that's what I did. So I ran it through the paces and charged it. I did all kinds of things, and it just absolutely, well, it didn't totally destroy it. It's about 8 volts now. So anyway, it's still twice what this one is, but still. Okay, so that's, and it's magnetic. Okay, I did that so you could see. And all right, so the next level, the next phase was, okay, here's an idea. Why not take this nice cell? It doesn't have to be 25 volts. It could be, you know, 6 or 10 or whatever, 12. And why not marry it with the super caps? Have layers of super caps in here. Now you've got a little power generating device that stores its old energy in its own little super cap layers. Beautiful, beautiful idea. But you still have another problem: energy density. Oh, shoot, okay. Energy density. Yeah, I knew that one was going to come up. So, next step: fix the energy density. Now, these are takeouts from an old, a couple of old handsets, you know, landline handsets. They're probably 10 or 11 years old, and they were plugged in for years. Anyway, they're 1.2 volt nickel metal hydride, so 4 of them should be 4.8 volts, but because they're so old, you're lucky to get them to charge up to maybe 4.1, 4.2, something like that. And this particular power cell is an 8 volt cell. I know this thing looks like a little bomb, but it's not. Anyway, it's pretty cool. So you drain the power. Now I've got this is a 12 volt 20 milliamp LED, and it's really bright. So you can see it's just totally bright. Of course it's, whoops, that's just these magnetic contacts. So you can run this and run this and run this, you know, until you totally drain these batteries, take the load off, and then the cell recharges the batteries. So you don't need outside chargers to do this. You don't need any kind of renewable. It does it on its own. So now there's a good idea. Okay, so with that in mind, can we make improvements on this even further? And here it is. This is the ultimate little cell. Now this thing, let me just show you. It's clamped in this little clamp. It's only about this is about a little less than 3/8 of an inch wide, and then the contact area where these, and they're just two long pieces of graphite. Basically, all it is just these pieces of graphite and the silicon crystal cell and electrolyte in between. So this is about a 1/2 inch of connection in here by this 3/8. So very tiny. So theoretically, this thing should be able to output maybe 0.6 or 0.7 volts consistently, you know, and be able to hold that, and perhaps up to 1 volt. So I put this together, and it's been, maybe about 5 days ago, and I haven't put it under a load or anything. I just wanted to see what it would do for the first 2-3 days or more, and see if it could hold, you know, if it could generate power, how much power it'll generate, how many volts it'll generate. Actually, just the volts is what I was interested in first, and how long it'll do that. Will it hold it day after day? So here's what it is. Let me move some of this. All right, so we'll just take the meter. Let's see if you can see those numbers. Yeah, I think you can. All right, and put the meter on it. 2.193, almost 2.2 volts on this little tiny itty bitty little sliver of cell. I mean, look at that. That's just, it's nothing. You know, and it's kind of like, and it's simple stuff like this. I mean, this is much simpler, but this is just a couple of carbon-coated pieces of graphite with an electrolyte in between. I mean, it's, you know, easy. You can make these in just a couple minutes, and everybody's doing it. So it's real easy. But this is dynamic, because not only does it exhibit a lot of voltage, but it also stores some of that as well, because it's also got that supercap layer in there, even though you can see that this is super thin in between those two plates. So there you have it. Okay, now that's the background. Sorry to take so long on that. That's the background that led up to these. And so now we're going to go into that. And here it is, BLACKBOX. I love this name. It's clean. It's simple. What is it? It's an output device. Just simple as that. There's positive and negative ports here. You can put banana plugs in here, or you can put wires. Just unscrew that and put a wire in there and clamp it back down, and you're good to go. And on the back side here, you can see in this area here are the silicon graphite cells, all in this area here. And in here, connected in series, are these 2800 milliamp hour Sun Labs batteries. They're nickel metal hydride, but they're the closest thing to lithium you can get without the hassles of lithium. So you got 11.2 amp hours of capacity from these batteries. So you drain down these batteries, not all the way. I mean, you know, use whatever you need to use, and you stop using it, then the cell regenerates the power back into the batteries, charges them back up, and you don't have to plug it in. You don't have to do anything. Now, you know, you could charge, you'd have to pull these batteries out, but you could charge this up through the front ports because of those supercap layers inside there. But I wouldn't do that if I haven't released this to the public yet, because I've got these 4 that I've gone through some testing for the last couple of weeks, and I just want to be absolutely sure that these things don't go out there like I saw another device went out, and I think there was like a 100% failure rate on it. I want these to be 100% success rate. So, you know, I'm willing to take the extra time. It doesn't matter. You may want this, you may not want this, whatever. I want to make sure that it's good. So anyway, that's what it does. These drain down, these recharge those, and on you go. So put the lid back on there. So the output on this, obviously, those are 1.2 volt batteries. So you're going to get anywhere from 4.8 volts to 5.8 5.2 or 5.3 volts, something like that. You know, it just all depends on how good the battery is. Those are pretty good batteries, by the way. So let's just take a look. Let me start the meter up here, sorry. Oh, I guess I turned it off. That was great. Okay, so let's just check this out and see what we've got here. And it should be a little over 5 volts. And there it is, 5.31 volts. Not bad. Not bad. Okay, now on the other cells, so this one's got the batteries in it. I left the batteries out of these other cells. I think they're all out. We'll take a look. Let's try this one. And so you can see what the cells themselves put out without the batteries. Okay, so that is 17, what was it, about 18 volts, and then pulls down about 17.6 or 17.7. This one, 18 volts, okay. This one, almost 18 volts, 7.94. So that's what, and again, there's no batteries in it, so you're just seeing what the silicon crystal graphite cells are producing to recharge these batteries when they're in here. And I will put them in here when I run the G1 in just a minute. So that's it. I just wanted to make this brief, this part, just to let you know. And there's a little it's an experimental device, so I doubt there will be any kind of warranty on these. That's why I'm testing over a period of time to make sure they're good. So, you know, so you get something you're happy with and you're proud of it and whatever. And it's the quintessential black box. Ooh. Anyway, it's cool. So here we go. Just a little extra note on the black box itself. I started to mention that you could actually charge this. Don't ever do it with the batteries in it. If you want to charge these batteries with some other device, take them out and use a smart charger, for crying out loud. But don't leave them in here and do that. But you can do this because of the supercap layer cells, you know, inside there, but I wouldn't do that because it's really strange, because if you start charging these things, they become dependent on that charge, and the next thing you know, they hardly want to put out their power anymore because they're looking for that charge. Now, as long as you don't do that, they'll just keep on cranking and cranking and cranking. So it's a really weird thing. But another thing is, don't ever try to short this thing out with the batteries in there, or you just get smoke, fire, and explosions, and you know, all those good things like that. But you can with just the cells, and just to show you that yes, this is live cells. There we go. It's 18 volts. All right, and this is a jumper. I'm going to use those in a minute to connect together, and we're going to run the G1. But I'm going to go ahead and put this thing in here and short it out. Bam! It is totally shorted out. Ooh, no heat, smoke, fire, nothing. It's just like the little micro generator cells. They just, you can short them out and leave it on there as long as you want, and it may take a little while for it to come back to full, but there it is, 17.4445, and in another minute it'll be back up to 18. So just wanted to go over that with you too. Okay, I wanted to show you the back side of this first, because I'm going to spin this whole thing around while we charge the big battery with the G1. But right now I just wanted to show you what the setup is here. These are in series. The black boxes are in series with the jumpers and so forth. You see the connection. It's coming into this little buck converter with the LED readout. Really nice, because these are producing about 20 volts now. We'll just call it 20 volts. Probably a little less than that because I had to preload these caps. So I can show you. You press that button and okay, so it's just under 20 volts, so not bad. It was probably maybe 20, 21 volts, something like that, because of the energy that was, the capacity was in them before they went into the caps. So anyway, but you can pre-charge these caps, whatever you want to do. It doesn't matter. These are all in parallel. They're 16.2 volt modules. They're Maxwell modules, so you get enough capacity. But these charge up those, and those run the machine, and so forth. It's just a very good way to have a higher rate of efficiency on these machines. So it doesn't put the load on these, it puts the load on these, and these just trickle it back in through the buck converter, and you can set that at exactly 16.2, 16.1. As long as it's close to 16.2, you're not going to hurt these at all. It keeps them at the top side, and everybody's happy. Just to give you a little zoom in on that, anybody that's got a G1 or is thinking about getting a G1, I can give you a link to get one of these things too, because these are just really sweet. I mean, if you go with a black box setup and you're looking for some other alternative other than typical renewables. So anyway, let me spin this thing around and we'll get started. Okay, we got the G1 running, and black boxes are feeding the caps, and we're running at well, right at close to 15 volts and about 100 milliamps, maybe not even quite 120 milliamps. So you know, less than 2 watts for sure. So let's see what the battery, I tried to pull that down a while ago, and it's at 12.72 right now, so it's not, you know, super discharged, but we'll go ahead and hook this up, and I think I'm gonna give it a little bit more current and let it run about 3 watts, 200 milliamps at 15. So what we're doing here is I've got power coming off the 3-phase rectified power coming in here, and it's mixing with some of the inductive power coming off of these coils, plus a little inductive back spike, which helps out too. Those are joined together and they're coming in right now into the battery. It's up to 12.74. I mean, remember, we're only running this thing on 3 watts. We've got 44 amp hours of capacity with these 4 black boxes connected in series. And we're only using 3 watts right now, and we're charging this battery. Now, I could put it up quite a bit more, and the charge rate will come up faster. It'll just pull these down faster. So it's up to you, whatever you want to do. I mean, if you had a bank, you'd want to set it a little bit higher, charge those up as quick as possible, and that's just up to whoever's going to be doing it. See, I could crank up the amps as high as I want to. I mean, I could take it all the way up if I wanted to, but I'm trying to be really conservative so that it'll do the job. See, I mean, it jumped up to 12.76 real quick like that, just a little bit extra current in there. But the fact that these can do it is pretty amazing, with no outside source, no other renewable source. And then they'll regenerate. Well, that's it for now. We'll keep in touch.